Hello again and welcome to Lecture 7 in my 8-lecture series on understanding science. Today I'm giving a short lecture on the subject of intuition. This subject has come up many times and really it's just a special case of one of those occasions where human beings make common mistakes in the application of the scientific method to the real world. But it's such an important special case and it raises so many interesting questions, and it exposes us to so many dangers, that I decided to give it its own lecture. In the next few slides I will explain what intuition is, where it comes from, where it's useful, and more importantly, where it can lead us down the wrong path. So let's get started. I've said it before in this lecture series and I'll say it again. Intuition may seem like the most reliable and obvious of all sources of information, but because of that it's one of the most dangerous, because it comes without any checks and balances. And this lack of proper verification makes intuition such a common source of error. And what's more, because errors in human intuition are almost always rather predictable, that means that it's very easy for a calculating pseudoscientist or fraudster to exploit it. What do I mean by intuition? Well, it's the sort of driver behind arguments that take the form, I mean, it's obvious, right? Or, of course that's true, it feels right. Or, don't be ridiculous, that clearly isn't correct. When not accompanied by detailed scientific counter-arguments, of course. And anyone who has ever paid even the slightest attention to debates around areas of pseudoscience and contentious topics that affect the scientific establishment today will have noticed that intuitive arguments form a huge part of the arsenal of any pseudoscientist. And the thing about intuitive arguments is that they feel, well, so plausible. That's sort of the point. Intuition is the sense that we all have that allows us to make instinctive judgments about a certain question without actually making any conscious calculations or measurements. Intuition is the sense that you use when you gaze across a wide-open landscape and estimate how far away a distant peak might be, or how long it might take to walk over there. Intuition is the sense that you employ when you quickly assess the plausibility of a claim that you've been presented with. Intuition is what we use when scanning through the newspaper, browsing the headlines and superficially deciding whether we believe what's written or not, and what we ought to do about it. So intuition has its uses, but surely it's been superseded by science now, right? I mean, it's all very well gazing across the landscape, estimating the distance to a mountain range, but now we have GPS and mapping technology, and so we can find out the precise distance to the nearest meter at the click of a few buttons. Intuition is perhaps still useful for our everyday uses, but in general we have much better ways of finding out about the world. Well, it's not quite that easy. Let's look at where intuition came from so we can see why it's such a fundamental part of our makeup, and why it's such a valuable thing to have around, even now. For almost all of the animal world, pretty much every decision that an individual makes is entirely intuitive. That is to say, a set of circumstances occur, and the animal makes a decision on what course of action to pursue, based on a combination of innate behavioural factors, subconscious learning, and a very superficial assessment of the current situation. Intuition is 100% heuristic. That is to say, it's 100% shortcut. Intuition is a very old sense, built up over thousands or millions of generations of individuals, each of which was biased towards certain courses of action based on their genetic makeup and, to a certain extent, the experiences that they'd learned from during their lives. Individuals with a predisposition towards social groupings, for example, may have survived slightly more often because the advantages of having a few friends around to help out clearly outweigh the disadvantages of sometimes being called on to help them out instead. So on the most part, we like to be in groups, we form friendships, we keep close-knit families. Similarly, individuals who had more of an argumentative disposition, who mistrusted authority and who tended to ignore what their parents and elders said, tended not to do so well in comparison. So we might imagine that human beings have certain predispositions to trust authority figures and to accept slightly too readily the reports of those we care about. And we've seen the result of this effect with problems like our susceptibility to appeals to authority. But of course intuition goes very much further. A good example is looking at numbers. We've evolved to live in small groups of individuals, maybe a few dozen to a couple of 100 strong at the very most. We may have evolved to keep herds of animals of a similar size perhaps. We roamed territories maybe a few tens of kilometres in radius, and we dealt with animals, trees, rocks, tools and other such objects that varied in size from a few centimetres to a few metres. The largest things we grew up with might have been mountains, say, and the smallest might have been grains of sand. We lived lives measured in decades, went on trips measuring days or weeks, had battles lasting hours, and human interactions lasting a few minutes. Hunts or battles could be won or lost in a split-second decision, maybe a couple of 100 milliseconds, probably no shorter than that. So what does this mean? Well, quite simply, those who are the best at dealing with lengths, heights, sizes, timescales of the orders that we most commonly encountered would perform better and would be more likely to flourish and survive. Those who didn't cope well with such concepts would have done worse. This evolutionary pressure would have made us rather good at dealing with circumstances like the ones above, but when we get outside the zones we're comfortable with, there's no reason whatsoever that intuition would be even remotely well tuned to deal with scales in thousands of kilometres or microns, or to deal with timescales of milliseconds or millions of years. This might not be an obvious question to ask at this point, but I suppose it's something I ought to comment on. Why bother with empiricism? I mean, intuition is largely pretty good. Why would we bother developing an elaborate system of scientific processes to supersede it? Why do we even care whether it's 10 or 15 kilometres to that mountain range, or whether it's 13,684 metres 23 centimetres precisely? Does it matter that much? To answer this, I'm going to answer the two underlying claims that I think are fueling this particular objection. First of all, why should we bother with precision? And secondly, why does it matter to learn the truth? To some people these might seem like daft questions, but I don't think that they are. There is an underlying assumption that runs throughout all of science that states that the truth is good, and that we should always aim to get closer and closer to the truth with everything we do as scientists. But the assumption is that this would generally be in the best interest of society, and it's not immediately obvious to me that this is the case. But let's answer the easier question first. Why does precision matter? Why would we need to know things precisely when an intuitive guess has always been good enough for our ancestors? In fact, if knowing values more accurately was in our best interests, then presumably our intuition would have evolved more accurately, wouldn't it? Well, not necessarily. For a start, there are several reasons why it might not even have been possible for our intuition to work more accurately. After all, there probably is a limit to the accuracy with which we can rapidly analyse the world around us. There's no way we could look at a crowd of 1 million people and accurately guess precisely the number of people there in one glance. So it's obvious that there is some kind of limit on the accuracy of intuition, but it's not necessarily the case that we've reached it. Perhaps our intuition could be a little bit better. The second point worth making is that evolution doesn't have an infinite patience and infinite resources. There is often a balance between competing forces. For example, if our brains were much bigger, then we might be able to deal with the world much more efficiently. But then there is a limit to the size of the head that can pass through a female's birth canal, and we're already at it. So in order to grow our brains as big as they already are, we have to be born very premature, when compared to other primates, that is. Making the brain larger would mean even longer as a dependent child before reaching adulthood. Maybe it's the same thing with intuition. Maybe it just wasn't worth our evolutionary ancestors possessing better intuitive senses, because it could only have come at the expense of some other sense, and after all, it was already plenty good enough for what they used it for. Cave-dwelling Homo sapiens didn't have much use for quantum physics after all. But we're not cave-dwellers, so it's really useful for us to have a much more accurate view of the world. It matters to us precisely how far away the moon is, for example, because we have a habit of firing rockets at it. And it matters that we understand relativity and quantum mechanics because they underlie much of the technology that shapes the modern world. So that's part one. Now, what about the truth? Why does the truth matter? A cynic could say that the truth is often cold and unwelcoming, like understanding the truly insignificant role that we play in the universe and learning about the inevitability of the heat death of the universe. Religions often fight against the progress of science because they see scientific understanding as woefully inferior to the revelation of their own scriptures. I guess I just don't see it that way. I look at the manifold advances that science has brought us in the modern world, and I realise that they're only possible because we understand the truth. If we'd stuck with the intuitive folk physics view of the world, we would never have learned about germ theory, for example. So maybe we would all been perfectly happy, assuming that diseases struck people because deities hated them, or whatever the assumption would have been, until they struck us, of course, and then we wouldn't have been very happy. It's not very easy to feel warm and cuddly when you're dying of smallpox. General relativity is much less intuitive than Newtonian gravity, but it's closer to the truth, and it keeps satellites in their accurate orbits, and allows life-saving technologies like GPS that we use to fly our planes. So knowing the truth has given us a huge amount. Sticking with intuition? Well, I can't see a single advantage that we can get from intuition, but not from a more accurate reading of the world around us. I don't think that ignorance is ever a benefit. Let's try a test. How long do you think it would take you to count all the hairs on your head? If you don't have many hairs left, then think about a full head of hair, maybe on a friend or relative, and imagine how long it would take to count every hair on him or her. Would it be possible in a human lifetime? 1,000 years? 100 years? Maybe 10 years or just 1 year? Could it be done in a few months? What do you think the length of time would be? Make a guess now without thinking too hard about it. So, it happens that the number of hairs on the average head is roughly the same as the number of seconds in one day. So something in the range of 80 to 100,000 hairs is the average, though it varies, and there are 86,400 seconds in a day. So if you counted 1 hair per second, it would take about a day to count all the hairs on a human head. If you counted 2 per second, you could get it done between getting up in the morning and going to bed at night, and still have a few breaks to eat. Did you think it would be that easy? Maybe you did, in which case, well done, but probably you didn't. Don't worry, there's nothing wrong with you if you got it wrong. In fact, your brain is absolutely 100% working fine. The brain isn't supposed to be able to deal with tens or hundreds of thousands of things, because you never needed to have that kind of intuition during your evolutionary history. Similarly, we're not supposed to be able to visualise the distance between stars, or the size of a hydrogen atom, or the age of the planet Earth, or any of these very big or very small quantities. One of the most obvious places where intuition breaks down is the old adage, don't judge a book by its cover. Or, in other words, don't assume that you know everything about a person based just on how they look. It's obvious where such an evolved sense would have come from. It's extremely useful to get a good idea of what someone will be like as quickly as possible, especially when one of the options is that this person might be a potential killer, or maybe a potential mate. It's not plausible to spend a few weeks getting to know everybody we ever meet, and sometimes it could of course be dangerous. An intuition is reasonably good at assessing personality based on looks, but it's not perfect, and that's where we get into trouble. I know several occasions where I thought I could tell what a person was like just by appearances, but I was horribly wrong. I have very close friends now who, when I first met them, I felt sure that I wouldn't ever get on with. Stereotyping is the process of assuming that all people of a certain appearance, or who possess a certain set of likes and dislikes, or who have a certain profession, are all alike. And it can be very, very vaguely accurate in general, but is very often wrong in specific cases. We meet a lot of people in this crowded modern world, but it always pays to reserve judgment just a little longer than your senses tell you to, and sometimes you'll be surprised. Intuition is also bad at understanding physical extremes. That is to say, scales and situations that would never have ever concerned our ancestors on the plain of Central Africa, who spent most of their time chucking spears at wildebeest. And there are many examples of this kind of intuitive limitation, just to pick the first few that come into my head. The extremely large. It's very difficult to get an intuitive grasp of the size of objects like the Earth itself, or the Sun, or the solar system, galaxy, universe, whatever. Even though I studied astrophysics and I can quote the sizes of these objects quite accurately, I don't have an intuitive grasp of how large they are, because the scales are ungraspable. The extremely small. Contemplating scales of the size of atoms, the wavelength of visible light, or even the comparatively larger scales of cells and viruses, is incredibly difficult for the human mind. Again, I can quote the wavelength of red light, but to imagine something that short is impossible for me. Extremely long timescales. It's very difficult for me to appreciate timescales like the age of the Earth or the universe as a whole. I think that's part of the problem with creationism, because human beings don't really understand what an incredibly long time evolutionary forces have in which to work, and consequently it's difficult to appreciate how much can be achieved in such timescales. Extremely short timescales. You may have heard that light can travel 7 times around the Earth in a second, or at least it could if it could travel in a curved path that accurately. But can you imagine just how quickly light could traverse a kilometre or a metre or the thickness of a human hair? Human events happen on the timescale of seconds, minutes, hours, days, years, but not longer or shorter events than those. Finally, there's very large numbers. We're not inherently very good at statistics, but a good chunk of that is also because we can't handle large numbers. You see, we evolved in groups of dozens, maybe hundreds at most of individuals, and maybe we had flocks of hundreds or thousands of animals. So what does it mean when I say that there are 10 to the 81 atoms in the known universe? That's a 1 with 81 zeros after it. I can't come close to appreciating that number. Even when I think of the comparatively small numbers like 300 billion stars in the Milky Way galaxy or the 100 trillion cells in the human body, I find those numbers almost impossible to comprehend with any kind of intuitive sensation. In other branches of science, we haven't evolved to understand relativity because the world we're used to behaves in a non-relativistic way. So when we're told that time itself slows down when we reach the speed of light, then that's difficult to comprehend. And we're used to thinking additively with velocities. So if I stand inside a moving train travelling at 30 metres per second and I throw a ball forward at 10 metres per second, the speed of that ball relative to the rails, which are stationary, is 40 metres per second. But when we get to relativistic speeds, say a train travelling at half the speed of light and a ball thrown forward at half the speed of light, the velocities don't add up simply like we might expect. Likewise for quantum theory, it's difficult to imagine some of the crazy-sounding results of the quantum world, like Schrödinger's infamous cat and the way light can be simultaneously a particle and a wave. And that's not to mention string theory and the extremely mathematical end of physics. And then in biology there's germ theory. It's difficult to imagine how something as tiny as a virus, which is so minute that you need an extremely powerful microscope to view one, could possibly cause potent diseases such as AIDS. So intuition is not great at understanding the type of discoveries that we're making about the world in the modern age. And that's why we need science. So we've looked at some examples of where intuitive reasoning fails. But where might it actually be dangerous to rely on intuition? I'm going to briefly cover 4 examples that I think are causing real harm in the world today, and I'll explain why they're dangerous and what we can do about them. Firstly, I've already mentioned stereotyping, which can often lead us to treat people more harshly than they deserve. But this can work the opposite way too. Millions of people around the world are taken in each year with confidence scams, dishonest marketing, rip-off salespeople and the like, merely because they've been able to win over their victims with a fake air of trustworthiness. And it's so difficult to say no to someone who you like, and who at least appears to be trustworthy. Thousands and thousands of people are taken in each year, especially in the US, by faith healers and other such charlatans, who convince them that they have the powers to cure cancer and other potentially fatal diseases, and make a fortune out of the trust and belief of their victims. After all, they say, he says the things I expect a good, honest man of God to say, and he has an honest face. Half a life savings later, and the disease is still as bad as ever, and the faith healer has bought himself another 3 Mercedes. Secondly, there's the naturalistic fallacy, which is extremely common amongst alternative medicine practitioners. The assumption goes that things that are natural, whatever that means, are better than things that are artificial. My favourite in this vein is when products advertise that they don't contain chemicals. And of course, every substance is made up from chemicals, even pure water and oxygen. The naturalistic fallacy comes from the fact that we have an intuitive attraction towards the green, the natural, towards blue skies and gently swaying grass with butterflies and a gently bubbling stream, whereas we're understandably revolted by the concept of concrete buildings paving over countryside and battery-farmed animals and the like. But we can take that too far. Many of today's medicines were once herbal remedies, which were then studied by scientists, analysed, taken apart and tested. Then the active ingredients were discovered, synthesised, purified, tested once more, mass-produced, tested even more, and then sold. We as a species owe a great debt to modern drug companies, spending the time and money and effort to carry out thorough scientific analyses on herbal medicines and to produce vastly superior, more powerful and safer versions, which we can then mass-produce in clean, controlled environments. An all-natural herbal remedy is merely the early precursor to an effective, safe drug before it's been made effective and safe. Thirdly, there's the bad news paranoia, and we see this all the time. Human beings evolved in groups of perhaps 100 individuals, so if major events happened to someone in that village, it was important to everyone. A murder was everyone's business. But now, living as I do in a country of almost 60 million people, roughly 3,000 people die every single day. So an extra person here or there really isn't a significant perturbation above the norm. And yet we fret so much over the threat like a lone killer who kills one innocent child every few years, compared to car accidents that kill thousands of people every year. The shameful and backwards retreat from nuclear power across the world is another example of this. The release of radiation from the Japanese Fukushima nuclear plant after the terrifying tsunami of 2011 is yet to claim a single victim, and it happened under once-in-a-century freak conditions. But the way the media is talking about it, it sounds like it could happen to any nuclear plant at any time and was worse than Hiroshima and Nagasaki combined. Consequently, several countries are scaling back their nuclear power plants and instead retreating to vastly more polluting coal and natural gas plants, the pollution from which will kill far more people over their lifetimes than nuclear ever will. Finally, there's good old Jenny McCarthy and her mummy sense. For those who haven't been following the unfolding public health catastrophe in the US, this concerns the mind-numbing stand by a fraudulent quack doctor and a handful of medically untrained parents against the entirety of medical science. They're claiming that childhood vaccinations cause autism, usually because of chemicals that the vaccinations don't even contain anymore. The claim has been comprehensively refuted, of course, but that doesn't stop them because they know that their intuitions just tell them that it's wrong, and that's good enough for them. Well, unfortunately, it's not good enough for them. It's not good enough for anyone. But I don't think that I could find a more fitting example for the dangers of letting intuition and worry take a higher priority than evidence and logic than this one example, which is now beginning to cause the deaths of small, vulnerable children. So we've heard a lot about what intuition is and why it's bad, but we haven't really thought much about how we can escape from it and learn to recognise the times when we're relying on our imperfect intuitive senses instead of a more reliable and more accurate scientific understanding. Well, I guess the thing to admit first of all is that a lot of the time intuition is great, and despite what I've said, there are times when it's enough, and there are times where intuition is really the only option we have. Times like encounters late at night when our intuition tells us which paths are safer than others. We don't have time to do a lengthy survey to find out if we're correct. Similarly, intuitively judging traffic conditions when driving can help us to avoid accidents. But for occasions when intuition isn't suitable, how can we get around it? Let's look at 4 examples of how a scientist would handle problems caused by intuition. Firstly, when we're measuring a known physical quantity. It depends, of course, whether or not we need accuracy. For example, if we want to know if a 2-metre wide vehicle will pass between 2 posts, we need only decide whether the gap is in one of 3 categories. Intuition can tell us easily whether the gap is much larger than 2 metres, in which case we're definitely okay, much shorter than 2 metres, in which case we're definitely not okay, or somewhere in between, which is the point at which intuition needs to take a back seat and more accurate measurement can take over. When we're measuring, we need apparatus that is suitable for the task. It should be precise, or at least precise enough for the task. Calibrated, that is to say, we should be able to trust that the reading it gives is not skewed by some internal fault. And it needs to be testable. That is to say, if we care about the result that the measurement apparatus gives us, then we ought to be able to test that what it's saying is actually accurate using some other method. Using apparatus to measure also gets around one of the greatest problems facing experimental scientists, namely human biases. And we all have plenty of these, such as the so-called Mueller-Lyer illusion that I've drawn on this slide. Which line is longer? Well, our intuition tells us that it's the top one, but in fact they're exactly the same length. A reliable ruler would tell us just that. Secondly, I want to go back and talk about peer review, which we covered in an earlier lecture on the scientific method. Peer review is the process that scientists use to analyse results before they're published. Before a paper is released to the whole wide world, it's shown to a select group of subject matter experts, who get a chance to analyse it for errors and suggest omissions or mistakes that the authors might have made. The thing about intuition is that, though we have broad similarities between us, no 2 human beings have exactly identical intuitive responses in each circumstance. So having a different person look over our work helps to highlight where we've made assumptions based on intuition that may not be correct. Statistical analysis and mathematics can also help us deal with the mistakes of intuition. Human beings are notoriously bad at dealing with probabilities and large numbers, such as in the case that I covered in an earlier lecture when a jury is told that a defendant has DNA that matches DNA found at the crime scene of a brutal murder, and the chance of a random DNA sample matching another is 1 in a million. Well, surely that means he's guilty. Well, no, as we pointed out, that means that there are around 60 people in the UK alone who would match that same sample just by chance. Similarly, if we take a test for a rare disease that's 99% accurate, and it's positive, then intuition tells us to be afraid. But a simple statistical analysis might help us. After all, a rare disease probably affects far less than 1% of the population. So it's much more likely that you're in the 1% of people who falsely test positive for this disease than that you're in the tiny microscopic fragment of the population who actually have the disease, and so on. Finally, there's experimental blinding, which is a vital process when conducting trials involving sentient beings. And blinding works by prohibiting the experimenter and the experimental subject from knowing the details of the specific trial that's being conducted. For example, in a drug trial, the volunteer doesn't know if they're taking a real drug or a placebo until after the experiment is concluded, so there's no way that they can bias the results, intentionally or unintentionally. And almost as importantly, neither should the experimenter know which is which. If the experimenter were not blinded, then experience tells us that experimental subjects could use intuitive feelings about the way in which the experimenter talks to them and the kind of body language they're using to guess whether or not they were being given a placebo or a real drug. And that could, of course, hugely distort the results. So that's the end of this lecture. There's not a great deal to summarise, as this one was a bit shorter than most, but let's go through what we've learned. Firstly, intuition is not a bad thing. It's hugely valuable in many circumstances. It is a strongly evolved sense, which has evolved to be of use in the sort of circumstances that our ancestors would have found themselves. Times in human timescales of seconds, minutes, hours, days or years. Distances in millimetres or centimetres right up to a few tens of kilometres at most, but not much more than that. Numbers from single digits to maybe a few dozen, maybe a few hundred at most. And intuition is pretty good in those circumstances. Not perfect, but pretty good. However, many experiences in the modern world require much more precision than that, especially the pursuit of science. So intuition can be a valuable guide, for example in estimating rough first-guess values that can later be refined, or in giving first-glance appraisals of strangers and strange locations that we would otherwise refine with more carefully judged knowledge. But intuition should not be an arbiter of the way things are. Intuition is not reliable enough for that. Here we should always reach for scientific tools and techniques. After all, science is merely the process of discovering the way the world is, of moving claims around on the spectrum of certainty as accurately as possible, avoiding all the known sources of error that we can possibly imagine. It has evolved over the centuries to give us the best chance of discovering how the world really is, of accessing the truth, and I believe I've given an outline case for why knowing the truth accurately and reliably is so valuable. Finally, beware of the dangers of intuition. Our senses and our intuitive mind are very powerful, but they're also very easily fooled. And when a sense can be fooled in predictable ways, then there will always be people who will make a lot of money from exploiting that weakness and duping the vulnerable. Don't be one of those victims, and help those around you to avoid a similar fate. Excessive confidence in our senses can often lead us down very unfortunate paths, and I urge you to be vigilant. Sometimes scientific theories feel uneasy because your intuition is tugging against the forces of reason. What happens if a spacecraft travelling at half the speed of light fires a projectile forward at half the speed of light? Is light a particle or a wave? How far away are the stars in the sky? How are diseases caused? What shape is the Earth? Intuition gives us very different answers to each of those questions than science does. And the scientific answer has been proven correct time and time again. In the next lecture, the final one of this series, I'll be doing a special tour of the most common logical fallacies that we human beings tend to fall for. That is, the most common mistakes of reasoning that tend to lead us into all sorts of trouble, not just in scientific endeavours, but also in our everyday lives. So tune in next time for the last in this series. In the meantime, I'll put the notes for this lecture up on my blog at frayn.net, where you can also follow the many other varied projects that I'm working on, and you can leave your comments and questions. In particular, if there's an aspect of science that you don't understand, then drop me a note, and I'll see if I can produce a presentation on that very subject. Thanks very much for listening, and I'll see you next time.